Okay. Let's see what we got here. All right. Okay, we're going to pick up now number 29 from the homework on partial fractions. Feeling good today. Doesn't feel like a Monday. Because it's not Monday. All right, number 29. So integral 1 over number 29, x cubed minus 1 dx. All right, well, this is definitely a rational function. We have a polynomial over a polynomial. The degree of the top is less than the bottom, so I don't need to do any long division. And I look at the bottom for a minute, I realize that's a difference of cubes. If that were x squared, we would be in business because we have a formula for that, but it's x cubed, so I'm going to use the difference of cubes formula from college algebra. So x cubed minus 1 equals x minus 1 times x squared plus x plus 1 dx. So you can check this yourself, that if you FOIL all that out, you should get back this. So now what we do is we look at this and we say, okay, we've factored this. This quadratic that's left here is an irreducible quadratic, so there's nothing we can do to factor that any further. And then we have a distinct linear factor here. So we have a combination of one distinct linear factor and one irreducible quadratic. So what that tells me is that I need to find a way of rewriting this as, first of all, a constant over my distinct linear factor. And then because I have an irreducible quadratic, I need a linear expression over that irreducible quadratic. And then this problem here, if we can figure out what B and C are, this problem will turn out most likely like the previous problem was. All right, so we multiply both sides by the LCD. So we multiply this on this side, it goes away, I have a 1 equals, we multiply this times this, the x minus 1's cancel. I'm left with a times x squared plus x plus 1. I multiply this by this, and the x squared plus x plus 1's cancel, and I'm left with the x minus 1. But that x minus 1 must multiply times this, which is why I have it in parentheses. So I'm going to go the long route here. I'm going to expand this all out. Ax squared plus ax plus a, that's distributing my a through. And then here I'll do kind of like a foiling. Bx squared minus bx plus cx minus c. And then I'll collect all my like terms together. So I have an x squared and an x squared. Put those together, pull out the x squared, place it in the back. I have an x term and an x term and an x term. So I go plus, and then now the coefficients. So a, and then minus b, and plus c, and then pull that x out in the back. And then I have an a here, and a minus c here, so a minus c. And then, hold on just a second. Hey, come on in, man. An a minus c here. And so now I'm going to go through and match up the coefficients, but I'm realizing that on the left side I don't have an x term, so 0x. I don't have an x squared term, so 0x squared. So I need my 0 to match up with a plus b. I need this 0 to match up with a minus b plus c. And I need my 1 to match up with a minus c right there. So I'm going to create my system of equations now. The system of equations, I have 3 unknowns and 3 equations, so a plus b has to be 0. Leaving a space here, a column for my c's. A minus b plus c must also equal 0. Okay, that coefficient on the x has to be 0. And then a minus c must be equal to 1. And so I look at this, and I could use my calculator, but it might be an easier way here. Let's see, how about we do this? Let's get an equation. Let's get an equation for a here. Let's solve this for a. And then I'll plug that back in here. And I'll get an equation for b, and then I'll plug that back in here. So solving this for a, I get a is equal to c plus 1. Okay, that's just moving the c over. Then I'm going to rewrite this equation right here. A plus b equals 0, but a is c plus 1. So that right there becomes c plus 1 plus b must equal 0. And then I'll solve this one for b. So b is equal to negative c minus 1. So I have a in terms of c, I have b in terms of c, and now I'm going to go back into this equation. I'm going to replace a with this, and replace b with this, and then I'll have one equation with just c in it. I'll solve for c, I'll come back and I'll get a, come back and get b. So, how's it going, man? Doing all right? What are you working on? Okay. Okay. Let me just finish this one up. I'm almost done. All right. All right, so rewriting this equation, a is c plus 1 minus, now b is this right here. So minus negative c minus 1, and then plus c must equal to 0. So I have one equation with nothing but c's in it. So c plus 1 plus c plus 1 plus c must equal 0. That's 3c plus 2 must equal 0. So c must equal negative 2/3. All right. And then now I can figure out what a is from this. So a is equal to c, which is negative 2/3, plus 1, which is going to be 1/3. And then b is negative c minus 1. So we said c was this. So negative 2/3 is 2/3. And then minus 1 is negative 1/3. So I know what a is, I know what b is, and of course I knew what c was to begin with. So now I'll go and I will rewrite the integral. The integral will be equal to, let's see here, we've got a over our distinct linear factor. So 1/3 over our distinct linear factor, which was x minus 1, plus bx plus c. So b is negative 1/3, negative 1/3 x plus c. So c is negative 2/3, so I'll do it like that. All over x squared plus x plus 1. So go back and look at the work I did earlier. This is a over the distinct linear factor, bx plus c, but c is negative, so, and that's it right there. So at this point, this one's going to be easy to integrate. This is just 1/3 comes out, natural log x minus 1. And this one's going to be a little harder, so let me do a couple of things here. I'm going to factor negative 1/3 out of this. So if I pull out a negative 1/3, now remember we have not integrated, so integral's still there. When I pull the negative 1/3 out there, I'm left with x minus 2 all over x squared plus x plus 1 dx. So just check, if you multiply negative 1/3 here, and then, oops, this is plus. Here to here, you get this, and then here to here, you get this. That's just a little easier to work with. So now, we have this situation where we have a linear expression over a quadratic, and so I'm going to play this little game right now, and I'm going to try and get this numerator to match up with the denominator. So I'm going to make a u substitution, x squared plus x plus 1. The derivative of that is 2x plus 1 dx. So I need this to be a 2x plus 1 up here. So what I'm going to do, I'm going to just cut this problem off right here. I'm just going to work with that. I'm going to take this integral, x plus 2 over x squared plus x plus 1. I'm going to force that to be a 2, so I multiply by 2 on the top, 2 on the bottom, and then I pass the 2 through. So when I pass the 2 through, it becomes a 2 here, and then 2 times 2, that gives me a 4. So far I've got the 2x taken care of. I need plus 1. So this is where I said just come in here and do plus 1, minus 1, and then we had a plus 4 there already. So that integral is now 1/2 integral 2x plus 1, then plus 3 all over x squared plus x plus 1 dx. And then what I'll do is I'll split it right here. I'll do this over this, and then I'll do this over this. This is actually a little longer than I thought it was going to be. So bear with me. Okay, so now this is equal to, and still I'm working with just this here. I have 1/2 integral 2x plus 1 over x squared plus x plus 1 dx. That's this over this. And then plus, I had the 1/2 still, 1/2 integral 3 over this. Now I'm going to take the 3 and bring it out, which makes it a 3/2. Then 1 over x squared plus x plus 1 dx. All right, the first one is easy because this is, u is the bottom, the derivative of u is on top. It's just 1 over u du. The antiderivative of that is natural log. So I know that this one's going to be 1/2 natural log of the u, which was x squared plus x plus 1. And that's by design. I wanted it to do that. That's why I forced this to happen. All right, this one is going to take a little more work because we have an irreducible quadratic with a constant on top. So that's going to mean that I'm going to need to complete the square here. So I take the x squared plus x plus 1. I take the number in front of 1, which is 1, divided by 2, and that's my first number. Then I take that number and I square it, which is 1/4. That's my second number. And then I rewrite this x squared plus x, and then I add 1/4, I subtract 1/4, and I still had a plus 1 there. So this, now, these three terms should guarantee to factor to be this, and I just need to figure out what that number is, and it's always going to be that number, so plus 1/2. And then I put these two together and get plus 3/4. So this integral can be rewritten with that. The denominator can be rewritten. So I'm going to go ahead and just rewrite it right here. This is x plus 1/2 squared plus 3/4. And now I just need to try and integrate that. So this is going to fall into the formula. If I make a basic substitution now, that u is equal to x plus 1/2, du is dx. We did this in the previous problem. Then this is just going to turn into 1 over u squared plus, this is an a squared, and that's going to be arctangent, the arctangent formula. So I'll get plus 3/2 times now 1 over a. Now what's a here? A is the square root of this, which is root 3 over 2. So we do 1 over root 3 over 2, which is really just the reciprocal, 2 over root 3. Arctangent of u, but u for us is x plus 1/2, over a, but a is root 3 over 2. What a mess. Plus c. All right, so remember all of this answer here was right here. So I've got to take this and distribute a -1/3 through, and I'm done. So I've got this 1/2 natural log x squared plus x plus 1, and then plus these two's cancel, 3 over root 3 arctangent of x plus a half over root 3 over 2, close it, plus c. When I distribute this through, we get a negative 1/6. Distribute this through and the 3's cancel, and I get negative. So this will become negative 1/6. And then here to here changes to a minus. Those 3's canceled. We should get that. And most likely, the back of the book, what they're going to do is they're going to multiply 2 here and 2 here to get these 2's to cancel. And they'll distribute the 2 through here, so this will turn into a 2x plus 1. I'm guessing. I'm going to check it real quick. This is number 29. One-third natural log x minus 1 minus 1/6 natural log of x squared plus x plus 1 minus 1 over root 3 arctangent. That's it. That's it. Okay. So what's up?
I'm trying to help my friend with his calculus going back to
Okay. You don't mind me recording this, do you? Okay. Just so I don't have to turn it off and make 2 videos. So what are you working on? Like what? Is it a limit?
Yeah, to me they're kind of simple, but I keep getting stuck on them.
Which one is it?
This is really together, but I was breaking it apart. 7x minus sine 3x.
All right, so I'm gonna help you with this Cal 1 problem, but I'll do it over here off